My data, all of my CSV file came here. So now it's time for me to solve question 1. So I think you can see this here is solving question 1. So first question say, is there any significant difference in the mean of weight on gender? Is there any significant difference? The mean of weight on gender. So, so in this question, our work will be with weight and gender. These two columns. So if I go to the if we come to Jupyter notebook, so for question 1, just say I can write a comment question 1. Then I have to write the code. So for this, I can do a t-test because this is a mean. They want here. Here they want the difference between the mean of weight of gender. They want here mean. So I can do t-test. So for t-test, I can write here code. For example, say I can take a variable. Just say t-test. Then I can also put a vector sign. After vector sign, I can say t dot test. This is the function for t-test. You have to remember it, t dot test. And then, and my work here is between weight and gender. They already say between weight and gender. So weight, WEIGST, is a capital letter. Then I have to press the shift and then upper button of tab at the corner. The sign weight and gender. Gender also here is the gender. Gender. Then after gender, we're going to put a comma. Then data. Who is data? Wait. I can write. Is this data? They want the from where? Weight and gender. It that data will be is equal to this data that we already declared variables. This data means this file. So I can write data. Then I close it. So after close it, now I can print it. So I can print means I run only test t-test. Now I can run it. So here they say data weight by gender. So t value here is 9, is df, and then p value they got the group 1 and group 2. The mean, right? They want just mean of gender and mean of weight. They want here. This is for until now here. Okay. So now second question said. Okay, let me create it is there. Second question. Now here the second question said the researcher wants to the review the figures of marital status data to see if all the status were equally distributed. If all the status were equally distributed. So in this time we can do the G-square test. Review the figure material status data to see if all the status were equally distributed. This time we can do is G-square test. G-square test will be between marital status so we need to do the G-square test between the marital status because we have a food type here. So in G-square test our DF value will be 3 because four type means single and married and widowed and divorced. Widowed and divorced. So four types. So our DF will be 3. So let's say let's first create a table for marital status. If you want to create a table, just I can write, I can take a variable, alright, marital, just I can say marital status table, status table, marital status table here. Oh, sorry, I can write here, this is question 2. So question 2 here, marital status table, I can also write underscore here because variable much should be here like this. Then I can say vector sign. And if you want to create any table, we have to use table function, table, table function. Then in where we want to create, we want to create the marital status table based on this four, like single, married, widowed, and divorce. So this column we are getting from data. So this time this one column relationships will be with data, means whole table. So we can write here data, and then we can put a dollar sign. This is the syntax, sorry, it's not this, dollar sign. And then I can write it this column. I can just copy this column, just a marital status. Wait, marital status. Control Z. Okay, wait. Delete data, and then we run it to like update it again. So I need what I need marital status. Control C, Control V, and marital status. So now is for we already create a table based on two and by in four way. Okay. Now I need to do the chi-square test for this table. So for example, I can create another variable that's chi and then underscore. Then say my square test marital status. Say square test, SQURE square test for, sorry, I also need to put here underscore. So square test for marital status. Yes, marital, marital status. So after that, this is the square test. We can use the vector sign, and we need to use another function that is cisco.test. Cisco.test means c square test. CHIQ. ISQ. Sorry. SQ.test. ISQ.test. Then I can, we want to do the chi-square test for what? For this table that we already created. Chi-square test. So we can just Control C and Control V. This table, this variable. So here, now we get, if I want to print this square test, just I can, now I want to print it. Okay, Control C, Control V. So now if I want to run it, this is the chi-square test, like a p-value here 10, and then chi-square test for given probabilities. The material status table, x square will be this, and df3, and it's the p-value 8.39 10. This is for chi-square test. So this is for question 2. Now question 3. Yeah. So question 3, what they said here, is there any interaction effects on between educational level and smoking status on the weight of the stuff? This is the question. So if you want to do this, okay, wait. We can take a look first to the what we need to do actually here. First, we can do here the ANOVA test. I say ANOVA is the analysis of variance. So normally in manually for ANOVA, we normally fill a table. But here, let's see what we can do for ANOVA. So first of all, we can create a ANOVA result table. See, the ANOVA will be, for example, here I can write a ANOVA result, a variable. I can create a ANOVA result. It's the vector sign. Then I can use the AOV function. Then our ANOVA will be one weight. So weight will be first. Weight will be first. Then it will be width, material status, and sorry, it will be the educational level and smoking status between these two. And let me copy again. Control C. Control C. So I can write here. Since you say N, so I can write here. It will be a smoking status. And from where? And the data, based on what data? Based on this data will be equal to this data, this table. So it's also named data equal to data. Now I turn off it. Now I can see the summary of this ANOVA table. See summary. Then I can say ANOVA result. ANOVA result of the summary here. Press this. Now I need to just extract the p-value for the interaction this term. P-value here. So for extract the p-value, we can write here just like the interaction p-value, the interaction of p-value will be summary of say ANOVA result. This ANOVA result. Summary of ANOVA result, and then it will show the third bracket. From the list, it will take the first element and to use the access to the first element of the list returned by the summary result of this ANOVA. And then this p-value here, it will be say greater than 5. And it will select the third p-value corresponding to the interaction of term. To let's start from 1 and finish until third. So here, then and the third value 3 interaction. After interaction here, now we can use control statement. If interaction p-value, this one, control C, is greater than 0.05, greater than 0.05, then for we can write here for the ANOVA row effect. Cholesterol this, and sorry about for